Good afternoon. It's nice to see all of you here. I am Greg. I'm with SOP, and I am now going to read the official statements to get this seminar going so that we can start listening to Frank's talk. Welcome to the 2019 World Dairy Expo. This afternoon's seminar is Climate Change, Reducing the Dairy Industry's Carbon Footprint, Greenhouse Gas Emissions in the Dairy Industry, presented by Professor Frank Mitloehner and sponsored by SOP SRL. Climate change continues to be a topic of great importance in today's society, and due to political leaders discussing the impact of agriculture and dairy, in particular, play in the current situation, the spotlight is on the dairy industry. Our speaker today, Professor Dr. Frank Mitloehner, is a professor in the Department of Animal Science at the University of California, Davis, and is an air quality specialist in cooperative extension. He is widely recognized as an expert in agricultural air quality, as well as livestock housing and husbandry. Mitloehner will discuss the overarching issues around a changing climate, as well as the role the dairy industry plays, both in the US and globally. He received his master's degree in animal science and agricultural engineering from the University of Leipzig in Germany, and his doctorate in animal science from Texas Technical University. Here's the important bit. This seminar has been approved for continuing education credits from the American Registry of Professional Animal Scientists and the American Association of Veterinarian State Boards, the RACE program. Forms are available in the back if you are interested in receiving RACE credits. At this time, I would like to ask everyone to please silence your cell phones. After Frank's talk, we will have a Q&A session, but now over to Frank.
Thank you very much, Greg. Good afternoon, everybody. What a pleasure to be back in Wisconsin. I have been here frequently over the last few years, and I always greatly appreciate your hospitality and being here. I don't always appreciate your weather, but everything else is great. So, yeah, I was asked to talk about climate change and how the dairy industry plays into this and everything around it. I know many of you are skeptics and skeptical in general about the reporting that we hear about livestock being a major driver with respect to the climate. No matter what newspaper, what outlet you read, you will hear frequently that it is the consumption of meat, of dairy, of eggs and other livestock and poultry products that drive the climate. I'm a skeptic of that, and I will share with you why. It's not that livestock and poultry doesn't have an impact, it does, but it's important to quantify it and to report it accurately, because only if we have fact-based information, we have public policy that actually allows for meaningful change. Before I get started with my content, I want to let you know that I'm on Twitter. About a year ago, I thought Twitter was stupid. But now I know I was stupid to have waited for so long, because many, many people follow me now and get a lot of really succinct information. I promise you that. And interesting discussions. So if you so wish, please follow me at Greenhouse Gas GHG Guru. And if you don't have a Twitter account, you want to change that, okay? So I have a few slides in here that just describe what kind of work a person like I do day to day. Research-wise, extension, and so on. So what you see here is a dairy in California rigged up with sensors, gases and particles transported through conduit systems into centralized trailers. And in these trailers, we have equipment measuring all the various pollutants that are generated on the dairy. Why do we do such things? We do that because we hear a lot of talk about how significant beef, dairy, and other livestock poultry systems are with respect to emitting pollutants, yet very little fact-based data. And so we actually had to go out onto commercial operations to measure, not just stationary, like here, but also measure what people are exposed to. What kind of emissions are people actually exposed to who work on a dairy? The notion you often find is that emission exposure is quite high. We wanted to know, is that true? Conducted a $1.5 million study and reported the data. It's all peer-reviewed and published now, and I can tell you that the original notions were quite false indeed. We have built facilities such as this. These are what people call the Bovine Bubbles. At UC Davis, we have built these large structures to allow for group-housed cattle housing that not just allows the animals to stay in a kind of a cozy environment, but we actually measure their emissions. The animals' emissions, but also the waste emissions, feed emissions, and so forth. We have 8 of those bovine bubbles, allowing us to compare different diets fed to animals or different ways to manage, let's say, the flooring and so forth. We have environmental chambers. So in addition to measurements, we conduct models or produce models that predict emissions. We're working with various other stakeholders throughout the country on developing predictive models on emissions. Most recently here in California, we now have a law that mandates a 40% reduction of methane to be achieved within the next 11 years. It's called SB, or Senate Bill, SB 1383. Again, it mandates a 40% reduction of methane to be achieved in 11 years by 2030, below 2013 thresholds. Now, every dairyman I talk to asks me, well, what were my emissions in 2013? And I have to say, I don't know. And then they say, well, how am I supposed to know? So all of a sudden, these topics become big. If you read or follow any kind of news, you might have seen what happened 2 days ago in Holland, in the Netherlands. Have you? I don't know how many farmers took their tractors on the road, but it was a road show, because there were 700 miles of upset farmers on their tractors, blocking everything in and around The Hague in the Netherlands, because they had enough of being critiqued for climate change and sold out, not sold out, but pretty much pinpointed as the major contributor to greenhouse gas emissions by part of the Dutch government. So 700 miles of tractors all over the Netherlands were a stark message to their government that the farmers are not willing to be accused of such a thing. Of course, they contribute, as I said, but they're certainly not the major contributor. Everybody in my field of work knows who the main contributor is, and that is the various sectors of society that emit carbon with respect to fossil fuels with respect to carbon emissions. We'll talk about this a little more. Here you see cows in head chambers. So we actually feed cows various diets and then measure enteric emissions, meaning those emissions that are belched out. And we find feed additives that further reduce that source, the enteric emissions. We also do work for the state of California, funded by the state of California, on various dairies where we monitor what kind of methane we might expect of a lagoon. Here again, we have a trailer that contains all the instrumentation. Here you see a flux tower that's located right by a lagoon. We actually measure those emissions so that our farmers know what they're emitting, so that if and when they're asked to further reduce their emissions, they can do so based on real data and not based on some theoretical numbers. So, and then last not least, I'm in the animal science department at UC Davis. We have 1,500 undergraduate students. We're the largest animal science department in the country. And I teach a class with 300 undergraduate students, really smart kids. You see a depiction of that here. Many of them become my graduate students. I always have 6 PhD students who then later become really important leaders, may it be in academia or in industry or in agencies or so. So I just wanted to give you these couple of slides to give you an idea of what the life of a person like Frank Mitloehner looks like. This, last not least, is a slide showing me teach dairymen. In California, all dairies are regulated the same way other industries are regulated. And here you see workshops conducted in front of 1,000 California dairymen on air, on how to reduce air emissions, on how to reduce greenhouse gases. These topics will not go away. You might think California is nuts, and you might be right, but the things that happen there will happen here sooner or later. It behooves you to pay attention of what's going on over there. Just like it behooves me in California to pay attention to what's going on in Europe, because that's where a lot of the stuff comes from from places like Germany, the Netherlands, Denmark. That's where it starts. 10 years later, it comes to California. Another 5 or so years later, it comes to you. So if you want to look into the crystal ball, there are ways of doing so. So I will give you a little background today around this whole climate change picture and how the dairy sector plays into that. So first, this is California from space. And I like this image. It shows the Bay Area here. This is San Francisco. Down here is Los Angeles. And this here is the Great Central Valley of California. This place produces half of all fruits and vegetables in the country. It produces 90%, 90 of all nuts. Well, no, Californians are nuts. And there's a proof, okay? 90% of all nuts produced in the Central Valley of California. We also produce, between Sacramento and Bakersfield, 20% of all dairy. But what this picture also shows is that we have unique kind of limitations with respect to topography. What you see here is the Sierra Nevada, one mountain range, and then the coastal mountain range on the other side, forming this huge trough, this huge valley that traps all the emissions that are generated either in the valley or that come in from outside. So any emission that comes from, let's say, China or container ships goes through the Bay Area, accumulates in the valley, and it stays there for a long time because of the mountains surrounding it, along with all the emissions that are generated in the valley. That, ladies and gentlemen, is the main reason why this place here around Fresno, California, is the one with the worst air quality in the country. That's followed by LA, and that's followed by Houston, Texas. So we have these issues, and they drive pretty stringent legislation and regulation. And because whenever you look out of the window, you see a cow, people think, oh, cows must have something to do with that. Images like that here are images you find in California. This is one of my favorite images of all. It shows the fence line. On the one side of the fence, it shows a dairy with 1,000 California cows. On the other side of the fence, it shows a recent urban encroachment. Why did these 1,000 households, why did they move there, you think? Cheap. The land is relatively inexpensive. You would still say it's crazy, but relatively inexpensive because it was formerly agricultural land, now redesignated. So people move there because it's relatively cheap. What's the first thing they do after they move there? Complain? No, they don't complain. Complaining is for losers. In California, you sue each other. The first thing they did was sue this dairy and others alike. And what do you think are the likelihoods of this dairy winning a lawsuit? Where do you think is the power on that picture, on the left or the right side of the fence? There's just no question about that. You have 2,000 voters here, you have 2,000 taxpayers, and so on. The power clearly is on that side of the fence. So whenever something like this is discussed in your planning commission or your board of supervisors, that people are supposed to move right next to your premises, you must be part of these discussions. You will not be a dairyman or a dairywoman good enough to prevent any kind of nuisances to be felt by these neighbors. They will smell you, they will get your flies, they will get your dust, and if it impedes their happiness, they will sue you as a result. And this happens over and over and over again. These are really terrible land use planning processes that I see happening in California and in other parts of the country and the world. We must avoid that because agriculture is such an important and strategically important part of society that any kind of scenario like that will seriously diminish the livelihood of our farmers. But now I talk about climate change. This year is the North Pole. The North Pole, and you see here the ice cap of the North Pole about 20 years ago, then in white the ice cap of the North Pole about 10 years ago. Today it's even smaller. For the first time ever, you can now take a ship and you can circle around the North Pole. We see changes in different parts of the world. We can see those, for example, using satellites. Places that were previously frozen, rock hard and solid, are now thawing, releasing large quantities of methane gas. We see changes throughout the world. And most scientists in the field that I work in will tell you that the main culprit of that climate change is the release of greenhouse gases. gases such as CO2, carbon dioxide, methane, nitrous oxide, and others. So I will kind of simplify things in order to make them well understood, but here's pretty much what happens. You have the sun radiating down solar beams to the surface of the Earth. Normally they'd be reflected back into space, but because of greenhouse gases existing and being in our atmosphere, they pretty much trap the heat and retain it. And they're pretty much forming a blanket around our troposphere. Just imagine a blanket around the Earth, keeping the heat from the sun in our atmosphere. This is really important. Without greenhouse gases, life on this planet, the way we live it now, would not be possible. It would be way too cold here, okay? So greenhouse gases are important to keep us comfortable on the one hand, but too many of them means that we have too much warming. The more greenhouse gases in the atmosphere, the more warming overall. So here you see CO2, you see methane, you see nitrous oxide, some of the greenhouse gases. Just remember, as a kind of a depiction, it's almost like a blanket around our troposphere. Here you see CO2 and you see methane and nitrous oxide. And most people, when describing the differences across those gases, will say they differ with respect to how much heat they can trap, or their so-called global warming potential. Global warming potential, GWP, describes how much more potent, let's say, methane is versus CO2, or how much more potent nitrous oxide is versus CO2. Global warming potential. And it's true that methane is a much more potent gas than CO2. But what you normally do not see during those discussions is that there are other differences as well. For example, CO2 has a lifespan of approximately 1,000 years. Once a CO2 molecule is in the atmosphere, it stays there pretty much forever. Any time that we have burned something on this globe here while existence of mankind, every time we burn fossil fuels, for example, we added new carbon to the atmosphere, new CO2 to the atmosphere, and it stays there, by and large. Some is gobbled up by oceans, some is gobbled up by plants, some is sequestered into soils, but overall, the majority of CO2 we put into the atmosphere stays there, and every time we drive our cars, trucks, planes, ships, and so on, we add additional carbon to the atmosphere. Remember, the lifespan of CO2 is 1,000 years approximately. That of nitrous oxide, the other long-lived climate pollutant, is shorter, but still hundreds of years. And this is in sharp contrast to the so-called short-lived climate pollutants. And methane is a short-lived climate pollutant with a lifespan of approximately a decade. Approximately a decade. So in contrast, let's say, to CO2, which lives for pretty much ever, methane is not just produced or emitted, but it's also destroyed. And the process by which that happens is called oxidation. I know this gets a little bit into chemistry 101, but it's important for you to understand. When a methane molecule is in the air, sooner or later it'll meet a so-called radical. And the radical will steal some hydrogen away from the methane, converting it into CO2. And that happens in 10 years. What most people will not explain to you is that methane is not just produced, emitted, but it's also destroyed and taken on by soils. So let me walk you through this. This here is from the National Academy of Sciences in the United States. It shows that globally there is a methane budget with emission sources such as fossil fuel production and use, agriculture, biomass burning, wetlands, and so on. And all of these combined produce about 560 what's called teragrams. That's the total amount. 560 teragrams of methane. But methane is not just produced, there's also what I just described, namely a destruction of methane. And if you look at the number, that destruction occurs at very high level. So while we are producing 560 globally, 550 are being destroyed or taken on by soils. Meaning the net methane contribution is not 560 globally, but it's 10. That's the net. And the reason is that methane, for example, if you run a dairy with 100 cows and you ran this dairy for 50 years, then you emitted new carbon, new methane the first 10 years, after which the amount of carbon of methane produced by your cows was equal to the amount of methane that was destroyed. Does that make sense? Does it make sense? This is really important, and this is depicted in this slide. I take you back to your high school years right now, okay? Photosynthesis 101. This is the sun. This is CO2. This is forage, either grass or corn. So what do we know about photosynthesis? What do we know about forages? What do plants need to grow? They need CO2. What else do they need? Water and what else? Sunlight. CO2, water, and sun. That's what they need. And where do they get the carbon from to produce carbohydrates, such as cellulose? Where do they get that from? They get that from here. That carbon comes from CO2. The CO2 in the atmosphere becomes cellulose that animals can ingest, particularly ruminant animals can ingest. And when they do ingest that, they belch out some methane. After 10 years approximately, that methane is converted to CO2 during oxidation. And this CO2 is at a lesser extent than the CO2 that goes into the plants that are eaten by the cows and so on. In this so-called biogenic carbon cycle, we are not adding additional carbon. This is very important, an important distinction. We are not adding additional carbon, additional methane to the atmosphere, because the amount produced by those cows equals the amount destroyed during so-called hydroxyl oxidation. This is a cycle. We are not adding additional carbon. This is in sharp contrast to the right side of this depiction, where we have fossil fuels that were stored in the ground for a very long time. That's oil, coal, and gas. We are extracting that carbon out of the ground, and what do we do with it? What do we do with oil, coal, and gas? We burn it. So where does that carbon go? It was in the ground for so long, we are taking it out of the ground, we are now burning it. And every time we do, we add new additional carbon to the atmosphere. On this side, we are cycling carbon from atmosphere to plants to animals to atmosphere to plants to animals. In this part of the greenhouse gas scenario, we are taking it from the ground where it was a long time, we are putting it into the atmosphere. And we are overwhelming all of those potential sinks, such as oceans and others, plants, because we are putting way too much carbon out there. Does that make sense? This is a story you probably have never heard before, but this is a story you need to hear. Here are some kind of, they are written in a technical way, but still understandable. Why short-lived climate pollutants such as methane should be treated differently compared to long-lived climate pollutants such as CO2 and nitrous oxide. This discussion here was started at Oxford University by Dr. Michelle Kane and Professor Allen. And I think their work is profoundly important because it really changes the way we think about methane from livestock. Methane from fossil fuels is a different story because there again, you take fossil fuels out of the ground, for example, by getting gas out of the ground, and when you do this, you get new additional methane from down there, you put it up there. That's not a cycle. Even though it's also methane, it's not a cycle. But in the biogenic carbon cycle of cows, we do have a cycle. You will hear about this discussion in the years to come. Many scientists have never had that discussion either. So you're not the first ones to hear this for the first time. Many of my colleagues haven't heard it either. So let's look at fossil fuels really quickly. Here you see the years 1750 to 2000, and you see in blue when throughout that time we took fossil fuel out of the ground and we burned it. As you can see here, the fossil fuel extraction happened over a very short period of time. And we have taken vast amounts of that carbon out of the ground. We burned it, and now it's in the atmosphere. And this is why fossil fuel use and particularly carbon emissions in the atmosphere are related. every time we burn that stuff, we add carbon to the atmosphere. When you have a barbecue and you put a sack of coal on your barbecue, what's left over once you're done? A little bit of ash. Where's the rest of all that carbon? It's up there. That's where the rest of all that carbon is. It's that simple. So what does the EPA say, the Environmental Protection Agency of the United States? What does the EPA say are the different sectors of society emitting greenhouse gases? This is the official emission inventory for the United States. The EPA says that transportation, cars, trucks, trains, planes, ships, emit 28% of our greenhouse gases. According to the EPA, power production and use is another 28%. Industry, they call it, and that's mainly the cement industry, produces another 22%. These three sectors, transportation, power production and use, and industry, are all fossil fuel consuming sectors. And they do what I just described to you. These three combined emit approximately 80%, 80, of all greenhouse gases in the United States. That is the 800-pound gorilla. And these very industries are running a campaign to make us consumers believe that we need to change straws and light bulbs and eat fewer burgers. In my opinion, this is a smokescreen to deflect off the 800-pound gorilla. That is my opinion. And many of my colleagues will share that opinion. Now let's go to agriculture, because agriculture is always in the forefront of being critiqued. Agriculture in the United States, that's animal and plant agriculture combined, emits 9%. Even though they use a cow to depict agriculture, this is not animal agriculture alone. This is animal and plant agriculture combined. Animal agriculture alone, according to the EPA, in the United States emits 3.9% of all greenhouse gases. Now you must be aware that all these numbers for all these sectors are what's called direct emissions. So this is an apples to apples comparison of all these different sectors. This is not a life cycle assessment, this is direct emissions of these different sectors of society. So if somebody says, and you oftentimes hear that, livestock emits more than transportation, that is complete baloney. It is a former assertion by a global body, the so-called FAO, that has since been retracted by the authors of that assertion. But they said globally livestock emits more than transportation. They have since taken that back. But that comparison is frequently used by activists to make people stop eating and consuming animal-sourced foods. It is not true that livestock, particularly in a country like this, emits more greenhouse gases than transportation or power or any other. You should know that the fossil fuel consuming sector emits about 80%, animal agriculture around 4%. That is the right ballpark. So that doesn't mean what you do has no impact. It means you do have an impact. But that impact is relatively small. We now know what it is, and that's most important, we even know how to further reduce it. And we have made commitments to further reduce it. And I will share those with you in a few minutes. If you think of the entire food supply chain in the United States and globally, from cradle to grave, from the crops growing in the soil and all the pesticides and herbicides and all that stuff going into crop production, when you think of animal production, when you think of what we eat and how we cook and everything from cradle to grave, what do you think has the most negative environmental footprint of our entire food supply chain? Guess. Somebody says transportation. Other guesses? Food waste. This slide here shows the National Geographic depiction of the food waste associated with one family in the United States. We are wasting 40%, 40% of all food produced in this country. That is the #1 environmental harm our entire food supply chain has. And what amazes me is that this number of 40% food waste does not only apply to the United States, it even applies to a place like Africa. But there for different reasons. Their food waste occurs because people can't harvest on time, or transport that harvest, or refrigerate it or preserve it. So there, the farm is more of the location of food losses, whereas here in the developed world, it's more at the consumer level. That's at your homes or in restaurants. 40% of food waste is a travesty. We should not have that. I think everybody here would agree that's unacceptable, right? The finger pointing has to stop of plant-based versus animal-based, and this diet is better than that diet. And we need to look at the true contributors to environmental harm. This is certainly one that nobody should feel good about. I can talk to you about this forever, but I shouldn't because I want to talk about some other stuff as well. By the way, are all food groups wasted the same way, same magnitude? What do you think is most often wasted? Perishable produce, and that's fruits and vegetables. Anywhere between 50 to 60% of fruits and vegetables are wasted. 50 to 60%. Animal source foods such as milk and meat are wasted between 10 to 20%. Still higher than we want, certainly, but it is actually the food group that's wasted at the lowest extent. So now I tell you a little bit about a discussion that brings those 300 animal science students that I have at UC Davis to the front of their chairs. I think it is a challenge of our lifetimes. And people call it the 2050 challenge. We oftentimes hear that human population on this planet is kind of exploding, right? You've all heard that. And then the question arises, how do we feed these people? This is what the 2050 challenge is about. On the x-axis, you see the year 1750 to 2050, hence the name 2050 challenge. And on the z-axis, you see the total human population in billions. I just turned 50, and when I was a little boy, we were right here at 3 billion people. Today, we are at 7.6 billion people. And by the time I'm an old man, we'll be at 9.5 billion people. In other words, please remember that throughout our lifetimes, human population on this planet will have tripled. Will have tripled. But the natural resources to feed these people will not have tripled. We will not have 3 times more land, water, fertilizers, and so forth to feed these people. And that, ladies and gentlemen, should trigger ethical questions as to how we should produce food in the decades to come. What's also interesting on this slide is that you see here in orange the human population development over the next foreseeable future in developed countries, such as the Americas and Europe, where we are plateauing, versus emerging and developing countries where human population is going through the roof. Not necessarily because everybody is now having 10 babies. I mean, yes, that is also an issue, not 10, but 5, 6 babies or kids per family in many parts of the developing world. But it's mainly a function of increasing life expectancies. People throughout the world grow older because there's better health care globally, there's better nutrition. As a result, people grow older, and cumulatively that means we have more mouths to feed. We all want to live longer, but that's what it means. We have more mouths to feed. The question then becomes, how do we do it? How do we do it? If you were to ask the population of Madison, Wisconsin, or Davis, California, at the farmer's market, how they think we should raise chickens, or pigs, or cattle, what would they say? What would they say? How many chickens should a broiler farm have, in their opinion, you think? How many? 10? Okay, maybe not 10. But most people I talk to in Davis would say no more than 100. If you have more than 500, they would call it names like factory, farm, and so on. You know, you've all heard this. Same thing with pigs. I mean, if you have more than 50 pigs in their mind, you are running something that they will not support. Most of these people are completely disconnected from reality. They have no understanding of how we grow food, what the drivers are of producing food, what the economic drivers are. I just taught my class that after raising a pig 171 days, the farmer makes a profit between $4 to $6 per pig. A profit of $4 to $6 per pig. If you are a broiler producer, you make 10 cents profit per chickens. Think about these numbers. There's something wrong here, right? I don't stand here saying everything that's happening right now in the United States or globally is good. I don't think that that's good. I don't think that's fair. I don't think our farmers get a fair share in general. And I'm here to put that on the record. But what I'm also here to say is, don't think that we can go back to the 1950s, where all animals are on pasture and where we have mini farms and so on. That will not feed the world either. So we have to think about how do we produce food in the most efficient way, still ethically sound. We have to think about sustainability. It's not a curse word. Don't ever think sustainability is a curse word. It's a very important concept, and you should be at the helm of defining and defending that term, because what you do is trying to be as sustainable as you can. That is your legacy as a farmer. So now I come off my soapbox and talk about global human population development for a few more minutes. This is one of my favorite slides. It shows the world and a circle over Southeast Asia. This circle here contains more people in it than the rest of the world combined. More people live inside this circle than outside this circle. I think that's a pretty amazing depiction. But while this is one of the hotspots of human population development, it's not the only one. Southeast Asia and South Asia will increase human population by 41%, whereas Africa will increase by almost 50%. And that's the 2050 challenge right there. The Americas will grow slightly, but not drastically, and Europe will shrink. So the 2050 challenge is really one of parts of Asia and particularly Africa. This here is another depiction of the same development. Here you see from a German publication, Southeast Asia. You see China will decrease human population, but other countries will increase by a quarter. And India already has 1.3 billion people, so increasing a quarter is a lot. But in Africa, we have a drastic development because those countries in red increase human population in a way that they double it every decade. Double it every decade. And these are the same countries that have the greatest challenges with respect to efficiencies of food production. So they have the greatest population pressure on the one hand, but also the lowest efficiencies of food production on the other. That's where the 2050 challenge takes place. It's not a question of whether we can feed people in the United States or in Germany. That's not the question. The question is, how can we help the rest of the world to feed itself, because else we will have mass migration happening that no wall in the world can stop. If you don't believe me, just look what happened in Germany 2 years ago, when in 1 year, 1 million people pushed into that country. In 1 year, mass migration had everything to do with this topic. So whether we have 3, 7, 9, or 12 billion people in the world, this here in color is the only cropland we have to feed these people. And we are not increasing that in any major way. I have a depiction here for you that I think you might find useful. Imagine this sheet of paper being the surface of the entire Earth. This is everything, okay? Sheet of paper, regular sheet of paper. I will now fold this sheet of paper, and I will fold it twice, until it's only a quarter its original size, approximately postcard size. This postcard size piece of paper is all land in the world. The rest is water and ice. This is all land, the rest is water and ice. This is my business card. The equivalent land in the world, represented by my business card, is all agricultural land. This is all land, this is all agricultural land. The difference between these two are forests and deserts and cities and so on. All agricultural land. Now I take my business card and I fold it into one piece that's 2/3 and the other piece that's 1/3 its original size. And then I rip my own business card into pieces. So the total thing is all agricultural land. The larger of the two pieces is what's called all marginal land. Remember that, all marginal land. Why is it called marginal? It's called marginal because either the soil quality is not good enough to grow crops, or there's not enough water. But it's 2/3 of all agricultural land, 70%. What do we currently do with that marginal land in the world? We graze it. We graze it. With what? With ruminant animals. Why do we do that? Because what grows here is the #1 biomass in the world, and that's cellulose containing grasses and legumes. Nobody else can digest cellulose and make it into valuable nutrients, such as, and that's exactly what cattle do, that's what goats do, and that's what sheep do. They use 70% of all marginal land in the world. If we were to do what our special friends want us to do, which is get rid of animal source foods, then we would effectively get rid of 2/3 of all agricultural land. We could establish some golf courses there, but we could not grow crops. We could not grow food there. The remainder of my business card, 1/3, is what's called arable land. This is the land in the world that we have to grow crops for people and animals. That's how resource limited we are. And this is why we have to think more than twice as to how we grow food to satisfy the growing global demand for food without depleting our natural resources. The IPCC, the Intergovernmental Panel for Climate Change, just wrote and published a report recently about land use changes and land use in general. And it was such an important piece of information. Unfortunately, a large sector of the media took this thing totally out of context and reported something that it did not say. The media pretty much reported, let's all go vegetarian or vegan in order to save the climate. That's not what this report said. It's not what this report said. So this here is a concept that's very important. It shows on the x-axis of this graph milk production per cow per year in fat and protein corrected milk. On the y-axis it shows the carbon footprint. Each dot here represents a normalized amount of milk produced per cow per country. So each dot here is one country and its dairy production. You see here that there are many countries with very low milk production per cow per year. So these are countries that produce 1,000 or 2,000 pounds of milk per cow per year. What's the average in the United States? 23,000 pounds. So where are we on this graph? We are not on it. We have fallen off. We are here someplace. Something to be proud of, by the way. Because what that means, what I just said, is that a country like India with 300 million lactating animals, both cattle and buffaloes, 300 million, we have 9, they have 300, produces a dismal amount of milk per animal. And the reason why they need such large herds is so that they produce the amount of dairy they need to satisfy their demands in the country. But they could do the same thing with 1/4 of their animals if they were more efficient. So what this slide really shows is that there's a direct relationship between productivity per animal and environmental footprint. The higher your productivity per animal, the better your efficiencies of production, the relatively lower is your carbon footprint. The same is true for all other environmental categories. And this is, ladies and gentlemen, where we are masters. The envy of the world. But we haven't taken our population on the right. They don't understand that. They don't understand, the people in this country do not understand the connection between efficiencies of production and emissions. But they are directly related in an inverse way. When the one goes up, the other one goes down. The more efficient you become, the lower is your environmental footprint. We know this, and the people in this country know this, when it comes to vehicles. We all know if you have a more fuel-efficient car today than your father did 40 years ago, then that means you need less gas to burn to get from A to B, and that means you have less emissions. Right? They all get that. But they don't intuitively understand the same is true for livestock. Here you see a US cow, and you see 5 Mexican cows. This one cow here produces 23,000 pounds. It takes 5 Mexican cows to produce the same as this one cow here. But she produces 500, and these 5 combined produce 2,000. So it is very important, and this is just Mexico. In India, that number would be 20. 10 to 20, depending upon what region of India, okay? This has a profound impact on environmental footprints. The more efficient you become, the greater is your impact. Here you see the Food and Agriculture Organization's depiction of dairy, greenhouse gases across different regions in the world. And what you see here is that North America does not have the highest, as many people think. We have the lowest carbon footprint of dairy production throughout the world. Throughout the world. People from all over the world come to Madison, they come to Tulare, to our World Egg Expo, to our World Dairy Expo, because we are the envy of the world in this field. But the people in this country, in those cities that read the newspapers we all read every day, they think the opposite is true. You know what I'm talking about, right? But it's not good enough for you to know it. We have to make sure that we tell the story in a different way, in a fact-based way. In the United States, the dairy sector contributes to 2% of total greenhouse gas emissions. This is the official number, okay? 2% of all greenhouse gases in the United States are dairy related. So it's not fair to say we don't have any contribution. We do. And nationwide, there is a commitment of the dairy industry to reduce its carbon footprint by 25%. In California, that commitment is 40%. These are commitments for greenhouse gas reductions that are unparalleled. You show me another sector of our society that has made these commitments. So not just do we know what our footprint is currently, and that's a result of a lot of research we have done, but we have committed to further reductions. So nobody can say that this sector of society is not compassionate, doesn't care about the environment. Do not allow anybody to say that. You are the stewards of that land you work on, and you want to pass it on to your kids. You better make sure that you engage in these discussions with the people who want to know. When a millennial or a Gen Z generation comes to you and says, how do you produce your milk? Is it true that there are antibiotics in the milk? You know, blah, 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 all these questions. The worst thing you can possibly do is, I don't want to talk, no comment, go away. I know what I'm doing, I'm good at it, bye-bye. That's the worst thing you can do. Use it as an opportunity to educate them because they have a growing interest in what you do. And you are the person who knows the most about it. I beg you to please engage with the growing number of people out there that wants to know what you do and how, because you have a lot to be proud of. We have a water footprint in the United States of about 5.1% of water withdrawal, total water withdrawal. That's sizable. It's not as big as some people think, but it is sizable. By the way, the on-farm water use is about 0.2. The dairy feed-related water footprint is 4.9. So that's where the majority of the water goes to that is related to dairy. What are the things that we have done to shrink our carbon footprint, our environmental footprint overall? 4 things. We have improved reproductive efficiencies. We have installed a veterinary system preventing disease or treating it. We have improved genetics of plants and animals, and we have learned to feed more energy-dense diets. The combination of these 4 factors has allowed us to shrink animal numbers to historic levels. Never before have we had smaller herds and flocks in this country than we do today. On the dairy side, we used to have 25 million dairy cows back in 1950. 25 million. Today we have 9 million dairy cows. So we went from 25 to 9, but today we produce 60% more milk with this much smaller herd. And that, ladies and gentlemen, means that we have reduced the carbon footprint of a gallon of milk produced in the United States by 2/3. Isn't that an achievement that you should brag about? Do you think the population knows this? We've done the same thing for beef. We've done the same thing for poultry. We've done the same thing all over. Not just for cars have we done that, but we have done it for the livestock sector. In a place that I visit often, China, the situation is different. What I'm now talking about is pre-African swine fever, okay? Before this devastating pest there, this devastating disease hit China. They are producing half of the world's pigs in China. A total number of 1 billion, that's with a B, 1 billion pigs are produced in China. But more staggering than that number is the fact that they have a pre-weaning mortality of 40%, 40. They are losing 400 million pigs per year pre-weaning. That animal loss number is greater than the entire US pig crop. That goes to landfills. And that's China. China is very modern, is very efficient compared to many other countries that are much less efficient. For example, India and many other places, developing emerging countries. So there's a lot to be improved throughout the world, and that's true. And it's another testament as to why we should never use global numbers to depict US livestock production, or Chinese, or Indian, or Angolan, or something, but use the numbers that apply to the locality where you're at. Our critics in the United States always have one strategy, and that is using global numbers to deter people in this country from consuming animal-sourced foods. They know these global numbers are not applicable to the United States, but they know the numbers look high, and so they are effective. That's what they're doing. They're never using US numbers. But when they do this, you need to know and point it out. So in the United States, from 1950 pretty much till today, our farm inputs have remained steady while our outputs have tripled. This is sustainability, to keep your inputs steady while tripling your outputs. That is exactly what we have done here, and that is why we are the envy in the world, in how we grow food. And this is the answer to the 2050 challenge. To remain input steady while increasing productivity, that is the recipe to feeding 3 times more people in our lifetimes. And the only recipe. It is not going back to 1950, small-scale farming and so on. This will not feed the world. This is what will feed the world. So one last slide here. It shows global greenhouse gas emissions. So think about all the greenhouse gases from human activity in the world combined. They amount to approximately 49 gigatons. Let's call it 50. 49 gigatons. Of the 49, 50 gigatons in the world, the US contributes 12. 12. So this is all the greenhouse gases in the world related to human activity. This here, these 3 slices, are the US contribution of the total. And the blue area here is the US fossil fuel-related contributions. So of all greenhouse gases in the world, the US contributes 11% of all greenhouse gases. And everything we eat in this country combined, animals and plants, everything combined, emits a total of 1.1% of all greenhouse gases in the world. So for those people who think that they can sell more plant-based burgers by scaring people into submission, and by telling people that whether you eat this burger or that will save the climate, they need to look at the actual numbers, okay? There's no way, even if we all abandon eating beef burgers or consuming real milk with soy juice or almond juice. I don't call that milk because almonds don't lactate. Even if we were to do that, we would reduce greenhouse gases by such a small amount that it's not measurable, it's not quantifiable at any scale. So, last slide. Can we eat our way out of climate change? I hear this all the time. If you, assuming you're an omnivore, if you were to go vegan for 1 year, you would reduce your carbon footprint by 0.8 tons of what's called CO2 equivalent. 0.8 tons of greenhouse gases by going vegan for 1 year. 1 transatlantic flight per person equals 1.6 tons. So, does going vegan save the planet and drastically reduce our carbon footprint? It will reduce your personal carbon footprint, but by an amount that's so small that it's definitely overblown by the reporting that we see day in, day out. A Meatless Monday done by all 320 million Americans would lead to a greenhouse gas reduction of our country by 0.3%. 0.3%, everybody going Meatless Monday. And the entire US going vegan would reduce the carbon footprint of this country by 2.6%. But the authors of that paper also said that while there would be a slight reduction of greenhouse gases, we would not be able to satisfy the nutritional needs of our population anymore. So can we eat ourselves out of climate change? No. What we need to do is we need to think very hard as to how we can replace fossil fuels and with what and at what time scale and so on. And you need to do what you have done so well for so long, and that is continue your path of being efficient, of being stewards of the land, and you need to change in one way. Not just do you have to do that, you have to start talking about it. You have to start talking about it. Don't just say nobody's telling our story. This is your legacy. This is your legacy we are dealing with, And so please know you have a responsibility of telling that story, whether it's in your family or in your community or beyond that. So with that, I want to thank you for your attention. Here's my contact information. I'm happy to entertain any questions you might have. Thank you very much.
Thank you, Frank, for the talk. If anyone has a question, I've been advised to have you raise your hand and then bring the microphone. All questions and subsequent answers will be on the record for those of you who might not want to be on the record.
I don't have a question. I'd rather help you with your argument in favor of cows. Before the Great Plains in the United States were inhabited by people, they were inhabited by bison or buffalo, who were also producing methane.
Yes, this is actually a very good point. The pre-European settlement of the United States, we had 80 million bison in this country. And they roughly are the same emitters of methane as a bovine today. Today we have 90 million beef cattle, so 90. We used to have 80 million bisons. Today we have 9 billion dairy cows too, of course. So roughly speaking, the amount of methane that was generated by those bison herds was not far off compared to the amount of methane that comes from our large ruminants today. So you're absolutely right. We know that. We have quantified it. It's already published. Now the question is whether people read it or whether people want to read it.
Well, I guess I have two questions. One question is, you know, they often talk about in the media, oh, well, if you didn't have cows, we would have forests. What's the net effect of using forest land for grazing for carbon emissions and whatnot?
So first, this answer here to your first question. In the United States, over the last 200 years, we had a net addition of forest. We don't have less forest today. We have more forest today than we used to. Most of the land that we use for grazing today were always used for grazing. The Great Plains were not some forest 150 years ago. They were the Great Plains. That's where the name comes from. But even if you compare the carbon sequestration of forages, of grasslands, versus the carbon sequestration of forests, there are publications, and I've just seen one from California, that would say that a well-run grassland, a ranch, let's say, sequesters a lot of carbon, particularly when you have grasses that are really productive, because these grasses suck up CO2, they assimilate it and sequester it. The carbon goes into the roots. These roots can be feet long. I mean, not 1 foot. They can be cirrus length, and they store the carbon and sequester it. So rangeland actually has a high potential to sequester carbon. If you look at the most recent IPCC report, or if you look at the most recent EPA reports on greenhouse gases, sources and sinks, you will find that agriculture and forestry, these two sectors, are a greater sink of greenhouse gases than they are an emitter of greenhouse gases. Because plants and soils are the two main sinks in the world of greenhouse gases. Both reports outline that, and I've quoted it on my Twitter. Some people like to read it, others don't.